together like a kind of glue. We can see visual evidence of these dark matter halos in other parts of the universe as well. We see the most dramatic evidence for dark matter in a celestial structure astronomers refer to as the Bullet Cluster. When astronomers looked closely at galaxies in the cluster, they saw subtle distortions caused by something invisible. The suspect? Dark matter. Astronomers used an X-ray telescope in space to detect massive concentrations of hot interstellar gas, whose bullet-like shapes give the cluster its name. The Bullet Cluster was formed when two smaller clusters of galaxies collided. If we could travel back in time to before the collision, we'd see two distinct clusters, each enclosed in its own cloud of dark matter. When the two galaxy clusters collided, the dark matter clouds passed right through each other. The dense clouds of gas and dust shown in pink, however, crashed into one another toward the center. What is this dark matter that can pass right through a galactic collision without interacting with anything? A dark matter particle like this one, traveling through space, won't let anything stand in its way. Dark matter doesn't exist only out in space. It's everywhere. Dark matter is all around us right now. If you hold up your hand, millions of dark matter particles will pass through it within the next minute. Particles you can't see or feel. As a matter of fact, there are billions of different subatomic particles flying through this room as we speak. This is the entrance to the Homestake Mine in South Dakota. It's the ultimate place to filter the dark matter particles out from the rest. In order to isolate the dark matter particles, physicists conduct experiments deep underground where most ordinary particles can't travel, but dark matter particles easily can. Every morning, dozens of scientists travel down a giant elevator shaft, 1,500 meters underground. That's almost a mile, to work with the most sensitive dark matter detector in the world. What they find in this subterrestrial labyrinth of abandoned mining tunnels could change the way we view the entire universe. This was once a thriving gold mine. But now, instead of miners mining for gold, the physicists who work here are mining for an even more elusive substance: dark matter. This is the Sanford Underground Research Facility. It's here that we'll find the Large Underground Xenon Dark Matter Experiment, or LUX for short. This tank filled with liquid xenon will be the perfect theater for witnessing the first appearance of a dark matter particle. The bait for detecting the dark matter particle will be the nucleus of a xenon atom. When a dark matter particle hits, the nucleus will give off a flash of light. or release electrons. These interactions will then be recorded by sensors on the bottom and top of the detector. Dark matter interactions of any kind are rare, but physicists hope they'll see one very soon. On the other side of the world, another group of physicists is working on creating their own dark matter particle. They're doing it here, at CERN, the world's largest research center for the study of particle physics, located outside Geneva, Switzerland. Here, thousands of scientists from many nations have joined together to track down answers to humankind's most complex and age-old questions concerning the nature of matter. Hidden beneath CERN's sprawling 450-acre, 2-square-kilometer campus and the surrounding forests and farms of the European